Welcome to Celestial Noise. Today, let's talk about moons. The definition of a moon is rather straightforward. A moon is a planet's natural satellite. That is, a solid object that orbits around a planet, just like a planet orbits around a star. Although this definition is very simple, it does lead to some arguments, as it doesn't specify how large an object has to be in order to be classified as a moon. Thankfully, everybody can agree that our moon is in fact a moon. Now, throughout human history, the moon has had a lot of cultural significance. People have used lunar phases to track time, as with the Greek lunar calendar, and have associated different phases of the moon with mystical superstitions, like werewolves coming out on the full moon. But there's nothing mystical about how lunar phases work. The Earth rotates in a 24-hour cycle, creating the day and night. The moon orbits around the Earth, showing a different fraction of its bright half to the Earth's surface at every point. When the bright half points directly at the Earth's surface, we get a full moon. When it points directly away from the Earth's surface, such that the dark half faces the Earth, we get a new moon. But this isn't the full picture. The moon itself also rotates as it orbits the Earth, in a special kind of motion called captured rotation. In the same time it takes the moon to complete a single 360-degree orbit about the Earth, like shown, the moon will also complete a single 360-degree rotation around its own axis. The result of this is that the same side of the moon is always turned towards the Earth. You can verify this yourself if you look closely at the moon, either at photos or with a telescope, and you'll see that the same craters and lines always appear on a moon's surface, no matter what phase it's in. Where did our moon come from? Was it formed at the same time as the Earth? The leading hypothesis, the giant impact theory, would say no. According to this theory, the Earth's moon was formed when a Mars-sized planet collided with the Earth some 4.5 billion years ago, when the Earth was already 50 million years old, sending a massive amount of material flying into space that condensed into the moon we know today. In a young solar system, these types of collisions are very common as planets are settling into their orbits. But with a solar system our age, we thankfully don't need to worry about something like that happening. Most of the planets in our solar system have many moons, although Mercury and Venus both have none. Moons can range in size from being very small, such as Deimos, Mars' smallest moon and only 7 miles wide, shown here in comparison to the moon, to very large, such as Ganymede, which is much larger than our moon, bigger than the planet Mercury, and orbits the largest planet in our solar system, Jupiter. However, just because Ganymede is the largest moon in our solar system doesn't mean it's the most exciting. In fact, there are several moons in our solar system that could potentially harbor alien life, most prominently 2 of Saturn's moons, Titan and Enceladus, and another of Jupiter's moons, Europa. When we look for alien life, we typically look at where we can find liquid water, as that's what we know is important for life on Earth. In 2005, NASA's Cassini spacecraft, which had been sent into space to study Saturn, its rings, and its moons, photographed geysers of frozen water spewing from cracks in Enceladus' southern hemisphere. It's believed that beneath the icy crust lies an ocean of liquid water, which is very exciting for astrobiologists. Titan is the only moon known to have a dense atmosphere, and the only object in space, other than Earth, where clear evidence of large bodies of surface liquid have been found. Harboring lakes of liquid ethane and methane, Titan may not harbor any life as we know it, because for what we like to see, we look for liquid water, but it is a very active place with a lot of fun chemistry going on that could lead to life. Finally, Europa probably has more liquid water than all of Earth's oceans. However, the surface of Europa is covered in a 10-mile thick crust of ice, making it impossible for us to see if any life might exist there, and meaning life would have to fuel itself using geothermal energy, instead of the sun's energy, like on Earth. But we can always imagine the sort of wonderful creatures that might live in the vast ocean beneath the ice, or in any of the other moons in our solar system. And I implore you to think about that, for when we talk about exoplanets and the possibility of alien life outside of the solar system in our next talk.